Hello everyone, welcome to Daily Leetcode Challenge. The problem that we are going to discuss now is searching for an element in a 2D matrix. So write an efficient algorithm that searches for a value in an m by n matrix. The matrix has the following properties. So integers in each row are sorted from left to right. The first integer of each row is greater than the last integer of the previous row. So basically all the elements will be in a sorted order. So if you take a matrix like this, so the elements, if you see, everything is in sorted order. So 1, 3, 5, 7, 10, 11, 16, 20, and everything. So everything from first row to last row, and in each row, first column to last column, the elements will be in a sorted order. So the straightforward approach that we can think of is start searching from the first row and keep searching every element in all the columns in the first row, then move to second row, then search in all the columns, then move to third row, and so on. So this is like a linear searching. So if your matrix, if the number of elements in your matrix is very high, this linear searching will not give you an efficient solution. So it takes more time. So to write an efficient algorithm, we can try a binary search algorithm. So binary search algorithm will give you an efficient solution when you have elements in a sorted order. So because the elements here are in sorted order, we can apply binary search algorithm. So let's look at examples first. So the matrix here given is this one, and the element that we need to search for is 3. So how binary search works is, first you take every row. So we need to find the row that contains the element. So how do we do this is, first you start from the left row, then you take the last row. So you take the middle row of these two. So if you have some 10 rows, so you take a first row and the last row, then you take a middle element of these two rows. So 1 plus 10 by 2, so it will be either 5 or 5th row. So you start from the 5th row. If the element, the target element is less than the element of the first element of the 5th row, that means you have to search in the first half. That means from the first row to the 5th row. If the element if the target element is greater than the last element, first element or the last element of the 5th row, then you need to search in the second half. That means you have to search in the you have to search from 6th row to the 10th row. If the element is in between, if the element is greater than the first element of the 5th row, and if the element is less than the last element of the 5th row, that means you found the correct row. Then you need to find all the columns. You need to find the element in all the columns. Again, you apply the binary search to find the element in the column. So in the second example, again we have target 13. So that 13 is in fact is not found in the matrix, so you have to return a false. So again you apply binary search algorithm to find the correct row, then you find the corresponding column where the element is found, and then you can have an empty matrix. So looking at the constraints, the size of the matrix can be 0 till 100. So you can have an empty matrix as well. So let's look at the source code, how we have implemented binary search. So initially we have a check for validation. So if the matrix size is 0, or if the column size is 0, then we return false. That means we cannot find the element in the empty matrix. Then you take dimensions of the matrix. So m represents number of rows, then n represents number of columns. So then we apply the binary search algorithm. So we take left equal to 0, right equal to row minus 1 index, max row minus 1 index. Then you try to find the row in which we can further find the element. So first, if the target is equal to a matrix width of 0, that means we found the correct element, we can return true. Then we check if the target is less than the first element of the middle row. So if it is less than the middle row, then we reduce our search space to half. That means we move our right index to mid minus 1. If the target is greater than the matrix of that middle row or last element, that means it is in the second half. So then we move our left equal to mid plus 1. If otherwise, that means otherwise the element is in the middle row. So the element is somewhere in the middle row. So we need to search in the middle row. So we set a left equal to mid and break the loop. and if the loop breaks in through while loop, that means left will become right. So in that case we have our target row as left or right. So we take target row as left. Here also we made left equal to mid. So then again we apply binary search algorithm to find the element in the columns. So again we do left less than right, then take middle element, so middle column. If the target is found in the middle element in that particular our target row, then we return true. Else if the element is less than the target element is less than the middle element, that means we move to the first half of the column, half of the space, search space. So if the element is greater than the middle element, that means we need to search in the second half of the row. So we move left equal to mid plus 1. So this way we finally break when left equal to right. That means either we found the element or there is no element in the current row. So that check will be added here. So when your target element is target row of the index the column index that we found, if it is equal to target, then we return true. Else, that means else there is no else we didn't find the element, so we return false. So let's execute the test cases and check. In fact, I have copied all the test cases provided, so let's execute all those. So yeah, our answer is true, false, false, false. Expected answer is same. So let's submit and check if it works or not for all the test cases. Yeah, so solution has been accepted. Let's check the time complexity and space complexity. Yeah, so runtime of 4 milliseconds for a total of 135 test cases, because we have applied binary search algorithm. So this is an efficient algorithm and we haven't used any extra space. So that's it. So thanks for watching. Please do provide your feedback. Thank you.